person, thanks for joining us online. Welcome to the live stream for T3. We're going to go through last term's exam, and we're going to go through advice on approaching the exam. And any questions, put them in chat. Stick your hand up if you're in person. And we've got an hour and 45 minutes. We might go slightly over time. I'm sorry, I was a bit late. And it's a 3-hour exam, but we should. I'm thinking it's very finishable for us in, I think we can do the programming in about an hour, and we can probably do the short answer in about, I don't know, an hour, 45 minutes. So we should have enough time. All right. Are there any initial questions before we start? Anything admin related, anything about all the exam arrangements, coming in person, anything like that? We'll get that out of the way now. No? Okay, excellent. So, oh yeah.
Oh, sorry. I had a question about testing out the CSV machines for the exam. Are we allowed to come in like this week to go into the CSV labs and just like set everything up and make sure it's all working?
Yeah, absolutely. You can definitely come in person. Go to. I don't know exactly when the labs. I'm assuming that most of the labs will be open because like there's no classes in them this week, so you can just go in and you should be able to have scan access. And yeah, you're welcome to go in anytime this week, test it out. If you can, like if you can get it for a couple of hours, do the sample exam on one of those computers.
Yeah. Thank you.
Yeah, okay. Cool. Any other admin questions? Otherwise, we'll leave them until the end. Yeah, Luke.
In terms of the exam, you can use Confluence and GitLab.
Yes.
Does that mean if I upload a file, if I push a file to my GitLab repository, I can still use it?
So you can only access the coursework that you've submitted. So your lab and assignment work. You can, like, if you wanted to go back and do a lab again, that would be fine. But you can't just have a Git repository that's just your personal notes. Yeah.
Okay. And if you had like a Confluence, if you made a new blog post that had stuff about patterns, for example, you would be able to use that because you're only allowed to use blogs.
Yeah.
Okay.
Yeah. So the coursework that you've submitted. I hope that makes sense to everyone. Cool. All right. Let's make a start. I will share my screen and share the entire screen. Cool. So this is copy and paste the exam that we gave people last term. I'm gonna, sorry Claire, I'm gonna bring this other projector up if that's okay. Just because I want to be able to talk to the screen. How do I? Oh, I don't need to. Cool. So let's go through it, starting from question 1. Structurally very similar, and the setup is all the same, where the spec will be on a Confluence page, and you'll get a Git repo personalized for you. That'll come out just before your exam sitting. So, all right, question 1. In each of the following code snippets, identify the logic error present and write a failing assertion that would catch the logic error as part of a unit test. Does anyone want to take a guess at this one for part A? We've got an equals method, taking us back to lab 2. I'm going to try. Do you mind monitoring the chat?
Yeah.
Anyone?
Returning 2 things cannot return 2 objects.
Oh, that's okay because we do this. We've got we're ANDing them together. So this will return a single boolean. There's something else. It all is like syntactically correct, but if you think back to lab 2 and how we're supposed to write the equals function, there's one logic error here. What's wrong with this line? Anyone online? Who remembers what this method is called? Or I can say what this method does. Anyone's memory can contribute? So when I say, like, let's say I have a class called animal, and have a class that extends that called dog. And so then I have an animal like A and a dog D. These are just two variables we've made. If I say D instance of animal, this is going to be true. Why?
Because it's some class, so it's still an instance of it.
Yeah, right. There's an inheritance relationship. All dogs are animals. Object isn't an instance of an article. Yeah. So what we want to do in the equals method is say no, not. Are these two of the same, like abstract type? We want to say, are these two objects physically the same, right? Is this article equal to this article? The problem with instance of, it's very useful, but the problem in this context is that we don't want to check if it's a subclass. We actually want to check that the exact type is the same. So in this case, maybe, maybe you have a subclass of article. That should return false. This return false should be triggered when we try to call the equals method. But that's not going to happen because of this inheritance relationship here. So then what we need to change this to is if not, or you can say like if object.getClass is not equal to getClass, return false. That would be the correct implementation. So that's the logic error present, is that it's using instance of instead of getClass. And then to write a failing assertion, you would just need to say, here's some sort of subclass of article. We're going to make an instance of that. Call equals. That will be true when it should be false. Right? So you'd say like assert false. Some extended class of article. Yeah. Okay, part 2. I really should get a eraser.
You're finding one.
Thank you. So this one, any ideas from anyone online, in person? We have a list of numbers and we go through all the numbers and we remove a number from the list at some point.
Yeah, is this because if you remove something from this list, it won't know where we're at. It might skip a number or two while we're looking.
Yeah. So we get this problem of you're iterating over something, but then you modify the thing that you're iterating over. Who knows what that does in Java? So if we run this code, and the thing about the exam is that you can take this, you're just on a computer, right? You can just take this code and run it and see what happens. You can play around with it. I wouldn't spend ages and ages doing it, but you could just take this code and if you run it, you'll see that a certain exception gets raised, which is called sorry?
Concurrency?
Yeah, well, it's not a concurrency error, but it's called a concurrent modification exception. So, it's a concurrent modification exception, which is essentially preventing iterator invalidation, where if you modify the thing you're iterating over, Java goes, no, you can't do that. It's not like Python where it'll just quietly have this problem, right? Because you've broken the preconditions and the behavior is undefined. Now we've actually said, oh, this is going to raise an exception in Java. So all that you need to do to say here is, well, I'm just going to, assert does not throw, and then call this function with, like 1, 2, 3, without blah blah blah, 1, 2, 3. And this is going to throw an exception. This assertion will fail. Pretty straightforward. So those two concepts test just your understanding of instance of versus getClass and iterator invalidation. All right, question 2. This takes us on to design principles. And really this is at the center of what the course is about. So again, these questions are very, very conceptual. They're very applied. There's lots of, here's this example. You've got to show your understanding of concept in relation to this example by talking about it. So the first one, no example, but the dependency inversion principle encourages programming to We have implementation on interface, interface on implementation. By the way, turned on. Also, if the online people can't hear me very well, just let me know and I'll talk closer to the mic. Because we can do that. Or we can use Claire's mic. Abstractions, not concretions, concretions, not abstractions, black box, white box. A lot of these things kind of just mean the same thing.
Sorry.
That's okay. You can see now, awesome. Anyone? Which might it be? This is pretty much copy paste from the lecture notes, and if you could, exchange the terms slightly. Anyone? The camera is a bit tilted.
I need a stand.
Oh.
You guys find the stand.
All right, well, I can understand. Okay, program to an implementation on an interface.
Why'd you put a chair on the table?
I feel like that's so dangerous. I could.
So the dependency inversion principle itself is programmed to an interface on implementation. So it's obviously not this one, and it's this one. There's multiple possible correct answers though. So we want a program to, here's my idea of like I don't know, something that flies. There's a flying, we'll call that an interface, and there's a method called fly. And it doesn't matter what this object actually is, right? This is just an interface. This is just like a front. Freeze that screen. It's just a front. It could be a plane. It could be a flying car. It could be literally anything. The point is that we don't care what it is under the hood. We just know that it has this behavior. Oh, thanks. And that's what we mean by interface. So similarly, out of these remaining four, what could it be? We don't care about what's happening under the hood, we just care about
Black box.
Yeah, so it's a black box, right? We program to a black box. And similarly, we program to abstractions, not concretions. Implementation, concretion, you can think of them interchangeably. Similarly with interface and abstraction, right? It's all the same idea. All right, that's 2A. Question 2B, consider the angle class and the maths helper class, right? So this is from assignment 1. First of those, we have angle, right? You store an angle inside it, and the point of this abstraction is to say, we don't actually care whether it's radians or degrees because you have methods that give you both. Under the hood, it's stored as radians, but that doesn't actually matter, right? And this would have been helpful for you in your assignment where you don't have to worry about converting between degrees and radians, you just store a different angle. So this is this is our angle class, and then the maths helper class is just a series of utility functions to help you do the calculations of the satellites. So which class is better cohesion? Does anyone want to give some sort of definition of cohesion? Just generally, right? Doesn't have to apply to software. If you talk about a team that has good cohesion, what does that mean?
They work well together.
They work well together. Yeah, exactly. Things just kind of fit well together. And so when we talk about cohesions in classes, that means, well, if I've got, here's a class here, here's another class here. It says, well, everything that's in this class belongs there, and there's nothing outside the code, like there isn't some code over here that really should belong in this class. And there's nothing in the class that really should belong somewhere else. And similarly, this class has content that's related to it, so that's, fields, that's methods, that's functionality. And there's not other code kind of related to it scattered around the code base. So we want to increase the cohesion as much as we can. We optimize for high cohesion and low coupling. So my question to you is, which one out of those two classes has better cohesion? You could really argue either way. You could say that, well, the maths helper has a lot of cohesion because it's got all the maths related functionality inside it, and there's this kind of concept of mathematics in the assignment, and that's all contained in this class here. My personal take on it is it's not as cohesive because it's essentially just a utility class, right? It's a series of static methods, which in itself is an indicator that this isn't really, you're not going to instantiate this object, right, like you would another class. You're just saying, I'm going to use this function, and the only reason it's sort of living in a class is because it's a logical grouping, which itself is cohesive, but not as much as saying, well, here's this idea of an angle, and here's all these methods that relate to being an angle, and here's this data that relates to being an angle, which is the angle itself. Does that kind of make sense to people? So I'm thinking about, what fits well together. Right. I'm gonna keep going. Question 3. Okay, you will get given a question like this in the exam. It will be the exact same structure, and it will be. Sorry, I've lost the whiteboard eraser. I'm like this clumsy. I know. Oh, it's on the board. It's like you're like, where are my sunglasses? And they're actually on your head. But yes, so yeah, you'll get given a question exactly like this in the exam. It will say, here's a scenario. You need to find the design pattern that's most appropriate to model this scenario in code. So if you were going to implement this, which design pattern would you use? It's one of the main design patterns we've covered. And when I say main design patterns, what I mean is, if you go to the course outline, sorry, the lecture schedule, this one, it has the word pattern next to it. So the strategy pattern, the state pattern, whatever, it could be any of these. You have to, in your response, say, okay, well, here's how the scenario, certain characteristics of the scenario relate to the characteristics of the design pattern. So each design pattern has certain characteristics. Like the strategy pattern is where you chop and change strategies at runtime. The state pattern is there's these states and these actions and transitions. For the composite pattern, you have your leaf nodes and your compound nodes. So hopefully throughout the term, you kind of built up this terminology or these sort of key ideas in your head for each design pattern. And now's the time where you have to read the scenario. Okay, well, it could be this one, it could be this one, it could be this one. For these questions, I like to do like a process of elimination where you just write down all the patterns and you go, well, it's not that one, it's not observer, it's not template, it's not whatever, and then sort of narrow it down to a few. That's one way to go about it, or you can just think about it in your head. So for this one, in 22T3, we're contemplating moving to Jira for students to manage their projects. There's 3 different types of Jira boards that can be used. So immediately it's like 3 different types of Jira boards. That's probably important. Okay, you sort of want to mentally highlight that. Okay, the 3 different types are Scrum, Kanban, and bug tracking. All boards have the same flow of work. Okay, probably important as well. And allow for features including support for issue tracking and customization of project-specific features. Okay, cool. So there's some stuff that's common across all 3 boards is the main takeaway from that. However, some elements may vary for each type of board. Scrum boards take 2-week sprints. Kanban has a series of epics that are progressed through, and bug tracking projects only have a single backlog. Okay, so what that tells us, the sentence before told us, okay, there's some stuff that's common, and then there's some stuff that's specific. And you think, okay, well, that's kind of what I'm used to with superclasses and subclasses. There might be some sort of inheritance relationship going on here, maybe. And then here's another important one. Once a project is created as Scrum, Kanban, or bug tracking, it cannot change its type. What design pattern could be used to model this? Anyone? Template? Yeah? Anyone online? Strategy. Yeah. Got a few votes for strategy. I think a lot of people said strategy when they responded to this question. And here's why it's not the strategy pattern. It's because of this sentence that's highlighted. The strategy pattern is like, A classic example is chess. You could also argue to do a state pattern. Sort of find strategy template interchangeable. Yeah, so this is a good point. The difference between the strategy pattern and the template pattern is, let's say, example. Let's go with chess. So here's your chess piece, right? And the thing about chess, you know, is when you move the pawn across the board and then you get to the end of the board and the pawn becomes a queen, right? So the type of the chess piece isn't necessarily fixed. So what you can say is, well, here's my piece, and I'm going to have a strategy, right? Composition relationship, and this is going to be an interface, which is called, you know, piece strategy. And then implementing that interface, we'll have pawn and we'll have queen. Okay. And what you know is that at some point the strategy is going to change, right? This is the point of the strategy pattern. I always say this when I shoot. It's like your strategy for doing COMP2511 at the start. You say, oh, I'll do all the labs on Monday, and then you think, okay, it's not going to work. So you change strategies, right? That's the key thing. You can change them. In this case, the pawn, it's a pawn, right, to begin with, and then it gets to the end of the board, changes strategy and becomes a queen. And you know, like in the restaurant example from the tube, it's like you can be charging at happy hour rates, and then all of a sudden you're charging at holiday rates, and all of a sudden you're charging. You can chop and change dynamically. The template pattern, you can't do that, right? Template pattern is this. I mean, this is the example for the template pattern. This is I would say the most correct answer. But try and give another one. Basically, let's say you didn't have this rule in chess, right? So all you had was, I've got a piece, and the piece can either be a pawn or a queen or a king or whatever. And it can't change its type. So in that case, you just have some plain old inheritance, right? Like this. You know, you've got abstract class, this is in italics, and then here are your subclasses that implement that class. Now, this is just normal inheritance, this is a strategy pattern. To make it a template pattern specifically, you need a series of steps, right? An algorithm of some form. You know, here's step 1, step 2, maybe these are defined in the superclass. And then step 3 is left blank. The subclass is going to have to fill in that. Maybe step 4 is also defined. And step 5 has to be filled out. So if I'm a subclass implementing this, I need to say, okay, well, this is step 3, and this is step 5. And then a different subclass will have a different implementation of step 3 and step 5.
Is this similar to the example of the we did like the queen, the king movement in that tube?
Yeah. So the template from the tube was when the thing with that one was the pieces couldn't change their type, and we said there's a series of steps when a piece makes a move. It does this and this, which is for all pieces, and this one next step is specific to what type of piece. So similarly here, it's like, well, there's a few things that are common to all types of boards, right? What is it? You've got your issue tracking, you've got your project specific features, but some parts are unique to each type of board. So the way the sprints work, that's undefined at the template level, right? That's what the users of the template have to fill in. Any more questions on template versus strategy? Why this is a template pattern? So when you give your answer, you say, well, this is a template pattern because here's the key characteristics of your template pattern are there's a series of steps. Some steps are filled out universally, and some steps are unique to each type of each class that's implementing the template, and then it can't change its type, right? It's not a strategy pattern. So they're kind of the 4 main points you need to hit on. You say, well, here's the sort of maybe snippets, quote it if you wanted to, or you can just paraphrase and say, well, because of this, this maps to a key characteristic of the template pattern. Cool. I hope that makes sense to everyone. Chuck any questions in the chat. Oh, yeah.
So when you describe like why this is a template pattern, we don't need to use very specific words, like exactly as in the refactoring website or something, right? Like the characteristics, because the website has like particular points. We can describe in our own words what we feel is.
Yeah, as long as you conceptually hit on the main points. I would say, like, if it's good that there's some keywords that you would want to use in your response, because a marker will look at that and go, this person, this person knows what they're doing. Sorry, let me just do the ref log. I had some notes here. Git reset. Nope, that's not what I wanted. Okay, never mind. Sorry, I'm just looking for. I had some notes here where I talk about the key characteristics of each type of pattern. Luke.
So are we also saying that part of the reason strategy pattern is very similar to template is because they both use an interface as well? Or do they not necessarily?
They could use an interface, they could use an abstract class, it could be whatever. It's not predetermined. Sorry, just give me 1 second. Speaking of doing my two-factor authentication for GitLab, you will be able to bring your phones into the exam room because you need to 2FA yourself into GitLab and Confluence on the CSE machines. But you'll do that at the start before the exam begins, and then you put your phones away. So just letting you know that now. That's also on the exam page. Someone asked on the forum, which was a very good question. Okay, I'm going to go back to sharing my screen. Here we go. So, sorry, to answer your initial question earlier of, I don't know what stuff's on Refactoring Guru. I don't like Refactoring Guru a whole lot because it doesn't quite capture the essence of the pattern quite well enough. It kind of focuses a lot on implementation details. But these are my notes on the key characteristics for each type of pattern. So if you came across this particular question and you thought, okay, I'm going to use strategy, I'm going to think about the strategy pattern in my response, then these are the points you want to hit on. You say, well, how do we dynamically change strategies at runtime? How can we add and remove strategies at will? And how is there sort of limited logic around changing strategies? This last one's mainly about differentiating it from state, where the more logic there is around how you change between strategies, the more of a state pattern it is. Anyway, I'm getting distracted and it's already 22. So let's keep going.
To access this repo, the solution samples.
Not yet. I'm going to push it after this topic. At the moment, it's the exact same as the exam repo because I'm going to write the solutions as we go. Also, I can probably give a sample solution to, like a written solution to some of these questions, but that will take time. Okay, question 4, observer pattern. Webster's waiting for tickets to the next Swans game, and he's got notifications on his phone that will alert him when the ticket's open. He's checking his phone regularly. There's a limited number of tickets, blah, blah, blah. He needs to be one of the first to save a place. So this one is a bit of a trick question because both answers are correct. So the push observer pattern says, okay, well, here is something that is being observed, right? Like maybe, actually, I'm not going to give another example, I'm just going to use this one. So here's Webster, and here is I'm trying to draw a swan. Here we go. This looks like 2. This is the swans, and this is the observer, the subject, and this is the observer. Now, either the subject can push notifications to the observer, right? So like when a YouTube producer publishes a video, I mean, like not sort of conceptually, they push out notifications to all their subscribers and say, hey, I've put out a new video. The other way is the pull observer pattern, where the observer actually pings the subject for updates. The example I like to give of this is, I used to do Army cadets, and we have these observation posts. So you have like these, find the whiteboard eraser again. You'd have like these target areas that we were trying to monitor, and there'd be some sort of fake bad guys doing some stuff. You know, this is your target area, and there's some people, and there's like a car and some trucks. And you have to make notes on it. The car drove in at this time, and they had weapons deal, and blah, blah, blah. And the idea is like they don't know you're watching them. So there's the target area. And this is your observation post. And here's like some binoculars.
I think the camera's
They can't see my drawings. It's so bad.
I can see the camera on my screen.
I think it's just not pointed.
Is it camera?
I can see it on my screen.
I think. Okay. Cool. It looks alright. Something. Let's see. Cool. So yeah, what was I? So you're observing target area, and essentially you're pulling updates. Again, this is the subject, and this is the observer. The observer pattern. They're the two types: push and pull. And in this case, the first type of notification is a push notification. It's literally called a push notification, right? Like you'll get those on your phone. That's classic observer pattern, where the swans send to the phone, right? Here's your notification. And the second type is also checking his phone regularly. That's a form of pull notification, where you pull updates from, in this case, it's just the phone, right? But it's from the subject. So both are present here. If you said either, you would be correct. I think to get full marks, you had to identify both as being correct. If I was going to do that question now, I would probably say either you get full marks, because it's a bit of a, it's a bit of a trick question, which is like, as long as you justify your response, it doesn't matter. Okay, so that's question 4. Question 5, code smells. You will get given a question like this as well, just like assignment 2. Hopefully you're getting better. Like one of the things I always read in people's blogs is like, oh, I want to get better at identifying design smells because it's really hard because the code looks fine, but then it's actually not fine for some reason. It's a really hard skill to develop. It takes a lot of time. And the thing about these like trimesters and stuff is like this stuff all takes a while. Like 10 weeks is a lot to go from kind of 0 to 100. So in that respect, I would say like do be patient because it does take time. Anyway, any initial thoughts on this particular bit of code? This is from assignment 1. People have written some stuff about the satellites moving around.
If it's the same, or if every satellite moves by different number,
yeah,
we maybe put the movement in the satellite class itself. Yeah.
So this is a good one. I would say like the smell is that you've got these sort of 2 blocks of very similar looking code, right? The only difference is a number. So you can say, okay, well, the first thing if you were to refactor this, you pull this out into a helper function, you think, and okay, well, maybe that's okay, but maybe we could do more. Maybe we could actually delegate it here instead of saying, well, I'm going to set the position in what's presumably a blackout controller or something similar. You say, I'm going to push this logic into the satellite itself. The second smell is your story. It's a very strange whiteboard. Oh, I've just drawn on the wall. Why it's a strange whiteboard? Oh dear. Okay, I'll fix that later. The second smell is that you have these 2 array lists which are both kind of, it's not duplicated data, but there's a level of redundancy, and most importantly, there's coupling there, right? Because now when you are operating on a list of satellites, you have to figure out which one you're operating on. So better practice would be you have a single list of satellites which contains both quantum and SAN satellites, and because you've already got the abstraction, you've already got the fact that there's some super satellite class, you just need to use that abstraction to your advantage. Now, all this question is asking us to do is say, code smell, what is it? And whether you think this is indicative of an underlying design problem. Because sometimes there are smells and they're just like, yep, that's a smell. That's it. Sometimes there's a smell and you think, oh, well, this is actually indicative of the fact that maybe this design isn't great. So in this instance here, you know, the fact that we probably could delegate this repetition here, there's coupling, there's an extent to which we could redesign this code to be better. So all you need to say is, yes, there's an underlying design problem. That's part A. Now for part B, we don't get a whole lot of code. This is probably a giveaway. Is there a specific name you have to give to the problem? Yeah, I would just say it's right? Like don't repeat yourself. It's just repeating code. You will need to, as long as you identify the problem, that's the main thing. If you can give it a label as well, that's really good. That makes it easier for your marker to go, yep, this person knows what they're talking about. And obviously it's less writing. Like if you just say the words, you know, the 2 for loops are evidence of don't repeat yourself, then that'd be enough. That's one thing. Other thing, I haven't seen it as much in the last couple of exams, but I remember the first time we ran this exam, not this exam specifically, but just for this course, that people would write these really, really, really long answers that were not helpful. You get like someone, you know, maybe a 5-mark question, and they'd write 2 paragraphs worth of stuff, and they'd get full marks, but there was a whole lot of waffle. And then you have another person who'd write 1 sentence, they'd also get full marks. So as long as you hit on all the points that you need to, all the conceptual points, then the length of your answer doesn't matter in terms of like word count or anything. Okay, so for this one, you're not given a whole lot of code, and that's indicative of the fact that, well, you know, we've got all these parameters, right? So the code smell is, there's a long parameter list. You could phrase that however you want, but that's the name of the smell. That's also how you describe it. There's just a lot of parameters. You think, well, maybe we could split this up. Maybe we could structure the design slightly differently. But the problem is, this is all the code we're given. We don't really have enough here to be able to make a definitive judgment as to, well, yes, there's an underlying design problem. Or maybe like all this does is just palm it off to someone else. Maybe that's a design problem. Maybe it's not. We don't know. So identify the smell. We don't have enough information to show if it's an underlying design problem. Could you say for part A, the code would violate the open-close principle? Absolutely. Yep, that would be a great response. And that would, like, that's the underlying design problem, right? Is that this code is not open for extension post-modification. Okay. Sorry, I think I read your entire question. Can't see it all. Oops. Yep. Okay. Question 6. This one, I like this question because I think some people in the auto marking had this problem where you submitted your code, and what you did was you changed something like position.java, which in this case is one of the files that we gave to you in assignment 2. And you said, oh, can we change position? Or maybe you didn't ask. You said, oh, we're going to change position.java for our own, you know, just because we wanted to make a change for our design. And you change it. You change the prototype. Sorry, this is wrong. Here we go. Position. Maybe you changed like this one here. Maybe you deleted this method because you're like, oh, we don't need this. We're not using it anywhere. The problem is we were using it in the auto marking, and in the spec we said don't change this unless we say it's okay. And whenever someone says, well, is this okay, which is what this question is asking, you just need to not break the preconditions and the postconditions of that class. We will rely on these for auto marking. And this is all to do with the Liskov substitution principle. So what you can imagine if you were thinking about this as being like a class is maybe you have this first, like a, when I say, this is all like a very conceptual example, but let's say you have a class called, I don't know, auto marking 1. And then you have another class called auto marking 2, which extends the first class. Now, by LSP, right, like this is the whole rectangle square thing where you say, well, you know, here's my rectangle and here's my square. And all squares are rectangles, so we can do this inheritance. Okay, but what about if you change the width? You know, so I say set width. And I do the same thing here. Set width. In the rectangle, you'll have like your, you know, length and your width. But in the square, right, they're the same thing. So the square set width will have something like, you know, at override, int length. And you'll say, well, length equals the new length, and then the width also equals the new length, right? Because it's a square. This breaks the behavior of what it means to be a rectangle, right? Because these are two separate things. You're probably all familiar with this concept by now. What does that mean in this example? Well, when we ran the auto marking, we assume that your code, right, or the interface is compliant with the original interface. So in that sense, there's this like inheritance relationship between the code that you submitted and the code that we gave you initially. Okay, you think, oh, well, this is all LSP. What does this have to do with design by contract, which is we referenced, I mean, yeah, preconditions and postconditions. So the preconditions and the postconditions mean, well, we expect the same thing. So if I give you this input, then it'll work. Remember, if you in design by contract, it's a new color. When we have inheritance, we can either weaken or strengthen or keep the same. And we can do that for the preconditions and the postconditions. If we weaken the preconditions, that means it is easier to comply with the contract in this subclass than it was in the superclass. This is like saying, if you can only, like, your original ticket is, you have to be of age, right? You have to be 18 or older. And then you say, well, here's this new ticket which extends the original ticket. And for that one, you can be of any age. So you weaken the preconditions. If you strengthen the preconditions though, and you say, no, actually you now have to be greater than 50, then I can't treat this as the original ticket, right? Because it's actually saying, well, no, now the conditions have changed. So it's like when you, one example.
Change of domain. Yes.
Yeah, it's like when someone says, oh, you say, okay, you're going to clean my house for $50, and then they rock up on the day and say, actually, it's $100. And you're like, that's not what I agreed to, right? So all bets are off in that sense. That's called strengthening the preconditions, weakening the preconditions. And then you can do the same thing on the other side with postconditions, except it's the other way around. So weakening the postconditions means saying, okay, I'm going to come clean your house, I'm going to charge you $50. And then they come and they don't clean your house. Or it's like you pay for something and then you don't get it. Right? The contract, or the thing that the ADT is providing, isn't doing that anymore. But if you strengthen the postconditions and say, well, actually, I'm going to clean your house and you get a free chocolate or something like that, right? It's doing more than it initially said it would, then that's fine, right? Like, you don't have any problems with getting free chocolate. So anyway, I've used like 50 million analogies to try and explain this question, but the upshot is you want to maintain the contract and you need to do that for the auto marking as well. So when people went and changed, like, and this is fine, like we can just rerun this, but when people go and change the prototype, right, they're changing the preconditions and the postconditions. Or when people change, I think that's the main one, is they go and change, like, they delete a method or something, or they you know, they say, oh, well, this one actually has to take in another argument now. So you're changing the preconditions and post-conditions means changing the contract, which is the auto marking break stuff.
So even if you strengthen the post conditions, which would give you what you originally had more, that'd still be considered breaking.
No, because you're giving what you originally had. As soon as you say, well, actually, I'm not going to give you this thing that you originally signed up for, then that's breaking the LP. I would say the best way to think about it is like, you know, you're paying someone to, I don't know, clean your house, or like the other example for this is you're paying for a flight ticket and, you know, you get more than what you originally expected. Well, they have all the fine print that's like, we can change your flight at any time, but you get the idea. It's like you need to be able to meet the conditions of the contract as the client, and you need the ADT or the service providing the functionality to also meet their end. So that's the end of the core questions. Now there's a lot of choice questions. There's going to be less choice questions in the actual exam, just because these are all interesting questions and we're going to go through and talk about them now. But one point of feedback that we had from the exam in previous terms that people found it a bit overwhelming. There was a lot, like they didn't have to do them all, you just had to pick two, but there's like, oh my God, there's all this stuff to, you know, all these questions to answer and stuff, and it's like a lot to deal with. So there'll be less choice questions in the choice section, but the upshot of this is you can read through them, you can figure out which one you want to answer, and you can pick one or two or however many. So let's talk about them now. Consider a lambda function. So this is all about the functional paradigm, the stuff we did in before. And it checks if the number is prime. The type signature has been redacted. So basically the job of this question is to figure out what the type signature should be. And what this function does is it takes in a number and determines if it's prime, right? Pretty simple. So what type of function is that? Does anyone want to have a guess before I go through it? So there's several types of functions that or I should say functional interfaces that you'll be dealing with. The first type is like a regular function. And you can think of this as being like a toaster, right? Here's my toaster, I put in bread, I get out toast. So it takes in a value and returns a value. And then you might have special types of functions, which is like a by function, which takes in multiple values and returns a single value, or whatever. There's multiple functional interfaces you can look at, and they work with generics, like you can see here. Function is takes in a value, returns a value. Next type is a consumer, which takes in a value, but doesn't do anything. So it's like the Cookie Monster, it just sort of eats the value up and then doesn't give you anything back, right? Nom, nom, nom. That's consumer. The next type is a predicate. And if you've done any of like the formal methods courses or for software engineers, Senge 2011, you know, you would have done things like predicate logic and all that kind of stuff. So a predicate is just a statement that's either true or false, right? The sky is blue, right? That's a predicate. That's just another function, right? It takes in an input and returns an output, but it's a special type of function because it takes in some sort of value, right? It's a generic value, and then it returns a Boolean, which is true or false. And I think if you even go to the documentation, predicate is a subset of function, or like an implements function. Now, if you think, okay, well, is prime, okay, well, maybe some of these are starting to congeal. And then the last type of functional interface is a supplier, which says it's like the opposite of consumer. Instead of saying, I'm going to take in a value and not return anything, I'm not going to take in any values, but I'm just going to give you stuff, right? I'm just going to give you whatever, right? You know, it's like a supplier of apples or whatever for a supermarket. These are the four types of functional interfaces. I mean, these are the main ones, I should say. There's more. But you can see immediately that, well, is prime it takes in a value, right? It takes in this n, it returns a value, so it's not going to be a consumer or a supplier. It's either going to be a function or a predicate, but all predicates are functions. So it's probably going to be a function. And the question asks which of the following answers could be correct and which is the most semantically correct. So it could be a function, could be this, right? Takes in an integer, n, returns a boolean. This is the input, this is the output type. It's not a consumer, it could be a predicate. It could be a predicate which takes in an integer, and it's not a supplier. So out of these four, which is the most correct? Well, immediately there's the ones with generics. There's the ones with generics and there's the ones without. It's better, better semantics, better type safety to say what the generic is, right? If you've done stuff with generics, you'll notice that when you don't give the generic parameter, right, you just like kind of cross this bit out. It says type safety, please parameterize this. Okay. So we want the generic parameter, which means we can rule out E, we can rule out A. Okay, which is the most semantically correct? Now I said before, a predicate sort of conceptually means a statement is true or false. What are we saying here? We're saying, well, is this number prime, right? That's a statement that's true or false. That's different from just a normal function, which is, like multiply a number by 2. That's not true or false, that's just a function. So we can also say, well, this isn't the most semantically correct. Like, it's still correct, but what we really want to say here is, and let me not draw the board on the wall again. Predicate integer is prime. That's question 7. All right, question 8. Sorry, during the project, CNN Group came up with the following testing plan. To make sure our code is fully correct, we're going to write unit tests to everything at the class level. We're going to write controller tests at the system level. And here's their test list. Now, immediately, the first thing you think is, well, they're the same list. And this is under the topic of test design, which if you did assignment 3, you would have done this like testing plan. We have to say, well, how are we going to test this? And we're going to have, we need to have some unit tests which actually work on the classes themselves. We need to have some system level tests which are on the controller. And we need some integration tests to make sure that everything works together as expected. And you can kind of think of this like testing as a spectrum of unit, where you only test one thing, to integration, where you want to test everything together. And unit tests, you want to minimize the number of dependencies between tests, because you just want to test one thing. You want to make sure there's one tiny piece of functionality is working. For integration tests, you want to have as many dependencies as possible. You want to sort of weave this web and catch any bugs that might be lurking there in the cracks. And any failing integration test, you should be able to write as a failing unit test. Rule of thumb. Okay, well, in this case, we've really just got a unit test list. Like, they don't really talk about integration tests. And what I mean by that is you've got unit tests at the class level, where we actually instantiate maybe a player object, or we instantiate a zombie object and work with those directly in the tests. Whereas this one, right, you're dealing with another layer of abstraction. So these are still unit tests, but they're not quite like proper unit tests because they've maybe got some they're testing multiple things interacting, but they try to sort of test one thing and one thing as much as they can. Okay, so that's not really relevant to this question, that's just background. The problem with this design is that you have, it's driving, right? You have the same test being written twice. And maybe they're going to be slightly different because they're working at different levels of abstraction, but you fundamentally have the same test list which creates coupling, which any repetition does, right? So now, if I add to this test list, then I kind of have to add to this test list as well. And you're kind of testing the same thing twice. And that just is more code, that's a bit of more code, right? And the more test code you have, the bigger your code base is, the longer your build times are, and all that sort of stuff for your what's it called, development loop. So that's a problem with sort of repeated test design, and it's a big thing in software engineering. How do we figure out a plan? How we're going to test this that's both going to test everything properly, but then also doesn't have this problem of, oh, we have repeated tests, or now we have a whole lot of testing code which we have to maintain and deal with. There's a big trade-off. The question asks us to explain why this is poor test design. Dry is the answer there, and give a possible alternative approach. So now you have to think, well, maybe the unit tests are okay. Maybe we're going to say, well, let's keep this entire test list for our unit tests, because these are all testing individual scenarios or behaviors or pieces of functionality. But then for the system test, we think maybe we don't need to test this all again at the system level. Let's just test the main flows. So, for example,
winning against mercenary zombie.
well, that's like winning, which is a single flow. So you kind of want to capture, like, the three main flows are winning, losing, and
Winning minus
invincible. Yeah. So maybe you have one test each. And maybe you say, well, actually in this test, I'm going to try and make it more of an integration test. So we're going to have, spider, zombie, and mercenary for all three. So I'm going to win against all three of these. I'm going to lose against all three of these. Or you have some sort of, like, a broader scenario, which you're testing at the control level, rather than here's this one thing. So maybe actually we don't want unit tests here. We want these to be more integration. This is all up to you as the test designer. Really, any sensible answer here will get you marks. But that's one way to go about it. That's definitely not the only way. 5:09. Okay, oh, we're not gonna have time. Well, how many more questions? I think I'm gonna try and skim through these ones, and then we'll get onto the coding. This question is to do with the topic on risk engineering that we did in week 9. Yeah, week 9. It's all about the floor and the plan, right? And this is not a hard question. It's just meant to be an example of here's where bad design can cause things to go wrong, and how could you prevent that from happening? This actually happened, by the way. So one term, we ran the auto marking. We cloned everyone's repos to do the auto marking, and we just missed out like 30 students, and they didn't get their exam markers didn't include auto marks, and they got released, and that was bad. So I thought this was a good example of what can happen when you have problems in code because it wasn't well designed, and when the process also didn't have the design to say, how do we prevent bad things from happening? So there's some stuff. Basically, when you run multiple Git clones together, GitLab implements a strategy to stop you from DDoSing it. So it just says, I'm going to skip this clone and keep going. So we only ran the auto marking on the present folders, and it meant that people missed out on their marks. They got them in the end, so it was fine. But the point is to say, well, what's the flaw in the design, and how could you have stopped this from happening? So really any sensible answer is good here. Like, maybe you needed something, literally just like checking that you had the same number of folders downloaded as there were number of students in the course. Like, that's a perfectly reasonable mitigation. Doing something like having like a sleep, where you say, well, if when you git clone, if the clone wasn't successful, then we're going to wait a minute and try again. So you have like a retry. Or what's another one? There's some sort of automated check to make sure that every student has an exam repo, or some sort of manual check. Any of those answers would be good. These are all just mitigations, containment barriers to prevent risks, or to prevent risks from actualizing. Okay, that's question 9. Question 10. This one, people love this question. When we wrote this question, I was surprised by the number of people that latched onto it, because it was it's like an essay. So you don't have to write an essay, but I think all the people's HSC English comes out and they're like, oh, here's my arguments for and against. But anyway, so there's a statement: all software development is maintenance. Discuss the accuracy of the statement above. This is really open. This is the statement that was in assignment 2. If you watch it, I would actually really recommend if you're interested in Scrum or Agile, watch that video about like how Scrum works and why it works. And one of the things that the guy says is that all software development is maintenance, because essentially once you build something, this is like the whole incremental design thing, where you just keep adding to it. You just keep maintaining, you add new features on top of an existing code base, you refactor, you improve stuff. There is like, the thing, you don't need to take this statement literally, which a lot of people do, because it's like, well, obviously, you know, there's a bunch of phases of the software development lifecycle, and they're not all maintenance, right? Like you do your requirements analysis, you do your design, blah, blah, blah. So in that sense, like not everything you do is the pure maintenance section, but the spirit of the statement is more like you're always working on something existing, you're always growing and evolving in this sort of incremental agile process. So in that sense, like really, basically all software development is maintenance. You could either argue for or against. You wouldn't get marked down for interpreting the statement a certain way, but it's again just like how well you can justify your position and draw on the concepts that we talked about in week 5 about how code grows, maintenance, and the evolution of requirements, right? Because you know new things come in all the time, and we have to adapt and evolve our code. Cool. All right, so that's question 10. Question 11. This is a UML diagram. Essentially, the state and the strategy pattern are present here. That's very easy to tell. You can see by the class names. Look at this, state, strategy, bang. And then all you need to do is like with the other question, except in reverse, where you're mapping the implementation to the key characteristics of the design pattern. So in this case, it's like your I action strategy has an action. That's your functionality that's being strategized. And then you can change them dynamically. See, I'm going to use the pipette tool, I'm going to use the image place tool, I'm going to use this other tool. So you just had to pick one and discuss that. All right, question 12. This one is to do with the async design with producers and consumers. This is assignment 3 kind of question. The problem with this, so you have a producer which puts in events into the channel, and then you have another entity which is a producer and a consumer. And I think this might confuse people with assignment 3 a bit, because you think, well, producers and consumers are different, right? But if you think about it at a higher level, like maybe I have this entire API, and that uses your producer library that you built in assignment 3, and it also uses your consumer library because it wants to consume events and then also to produce them. So in that sense, this entity is both a producer and a consumer. It's like how, you know, when you like on YouTube, if you both produce videos and you watch and subscribe to other people's videos. So this reads events from the channel, but also puts events into the channel. But these are of the same type, or in the assignment 3 speak, they're in the same topic. And so the problem with this design is, well, you consume events and then you produce events. Because they're of the same type, right? They're red events. And you can see here from the diagram, it's like you're essentially just eating your own vomit, where you just consume the events that you literally just produced. So it goes round and round and round in circles and you get an infinite loop. In a more general example of the observer pattern, it's like if it's like if, you know, in a hospital system, if you can be a patient, but like a doctor can also be a patient, and so you can't be your own doctor, right? It's like in those law shows where like the lawyers get taken to court and then they try to backseat drive their own case. And it's like you can't do that. So they try to like represent themselves or whatever. So it's like that. So you can't be both the producer and consumer of the same type of event, because you just end up with this feedback loop. Great, 5:16. Okay, we're going to take a break and then we're going to get into extended answer. I feel like we'll be here past 6, but I'm sure people appreciate that. Ideally, how long should you spend? That's a good question. Actually, it's a great question. I might just talk about that for a bit, because sometimes one point of feedback is that sometimes people spend a lot of time on the short answer. Don't burn all your time on the short answer. If you can't answer like some of the questions, come back to it later, because some of these questions you kind of maybe just need to think about a bit, even if it's unconsciously while you're doing the other questions. and then come back to at the end. I mean, it's up to you how you split your exam time. It depends on what you're trying to achieve and how, how much of the exam you want to attempt, and really like do the sample exam and you'll get a good feel for how long things take, because it will be very similar to the sample exam structurally, stylistically. But if I was doing it, I would try to get the short answer done in half an hour. That's my guess. It's a 3-hour exam. You want to spend as much time as you can on the coding, but this is like a pretty big chunk of the mark, so don't neglect it. At the same time, like if you go more than half an hour, then I would say move on to the next section. Okay, 10-minute break. We'll come back and we'll do extended answer very quickly in 10 minutes, and then we'll do some coding. let's continue on.
You might want to stop shit. Oh.
Oops. Yep. Here we go. All right. This question, extended answer. Don't draw us a UML diagram, please. I mean, you can't because you can't access Lucidchart because you can't only access GitLab and Confluence in the exam. But we got a bunch of UML diagrams last term, so don't do that. All you're doing is an API, and what I mean by that, I'll show you in a second. We have a system here which blah, blah, blah. Many online newspapers such as Sydney Morning Herald provide a special type of article called a live article, which uses the benefits of real-time updating to provide news stories to users. Basically, there's an article and people, you know, the journalists make posts. You can see, you know, 740, 749, blah, blah, blah. So in this question, which is kind of similar to assignment 1, except only the first bit where you just did the design. You say, well, here's what the classes, the entities are going to be in the system. Here's the relationships between the entities. And that's it. There's no implementation, there's no coding, it's just design and prototypes. So here's our requirements. We'll look at those more in a second. You need to model the domain for the above requirements to form the basis of a potential software solution. Your answer should include blah, blah, blah. Interfaces, these are all signatures, right? Class signatures, prototypes, which include inheritance relationships, method signatures. And then here's the other one is you need to show, just as like a comment, aggregations, compositions, and cardinalities. And I'll give you an example of that in a second. And an interface for the entire system has been provided in blah, blah, blah.java. You can modify these if you like. So there's no auto marking for this question. It's all just design. And here's what you'll be assessed on. This will be the exact same as this question in the real exam, except the scenario will be different. It shouldn't take very long. And I said here, it's like, take 10 minutes. If you're spending more than 10 minutes on this question, you're probably overthinking it and going into too much detail. It's literally just the basics. Let's do it now so we can see what we mean. So let's go to question 13. Oh no, sorry, git reset. Hang on. I need to copy this and reset again. Sorry, head 1. I did this as revision just beforehand. Nope, git reflog. Why isn't this working? Okay, there we go. Oops. So this is the exact same as the starter sample exam repo that we gave you, and these are the method prototypes. I'm just going to go back and fix the advice section here, which now is not working. Okay, that's fine. Requirements of the system. A new live article can be created, storing the first time it was created. Okay, let's do that. Move this over here. We'll make a new file called livearticle.java. That's going to be a class. It's going to contain private local date time created. What else? Okay, a post can be made on the article. So we'll say private list posts, which includes the content, blah, blah, blah. Okay, so we're going to have a class called post, which we haven't made yet. And let's just import these. Your code should compile for this question. You'll need it to compile to get the other questions to compile because it's all in the same project, but you won't have to execute it. So that's good. Now let's make a new class called post.java. Okay, so the post includes the content, private string content, private string title, and private local date time created. Let's also add a constructor. Don't need to put any code inside it, it can all be empty. Okay, and a comment can be made on a post. So let's have a private list of string comments. Okay, that looks pretty good. We've got the created posts. Now let's flesh out this. Let's just flesh out the relationships between the entities before we do the functionality. One other thing is that the live article system will need to have a list of live article objects. It's going to be private. And I'm just going to write a comment here that says a composition. So this is a composition relationship because if you remove the idea of a live article system, then there's no live articles, right? That's kind of by definition, you need some live articles to go on the live article system. Because this is all kind of virtual, it's not like the engine with the car in lab 3 where if you take out if you remove the car and just have the engine on its own, the engine can still exist. Where it's like, if you take an article or you take the system away, it's like, well, there's obviously going to be no articles. Similarly, probably the most important one is like, okay, well, a live article has a series of posts. If you take away the idea of the live article, then the posts don't really make sense, right? You don't have, for this one, it's like the posts don't semantically have any meaning if you take away the article as a whole. So composition, not aggregation for all of these instances here. So I'm going to say composition, one article has many posts. You can say like 1 star, you can use whatever syntax you like as long as it's clear. I'm just going to write it out in plain old English. Similarly in here, composition, one system has many articles. That looks good and created. Now, let's add a constructor. And now in the system class, let's start to think about how we would add functionality. First one is creating a live article. So we'd create it here and it will return a string. We can assume that's going to be some sort of ID. So let's say I'm going to create an article. I'd use the live article constructor that we've just made here. Probably don't need to add anything else. All right, let's create a post. Now we get given the article ID and the time created. So if you were thinking about implementing this, you'd maybe say, okay, we'll stream through all the articles, find the one where the ID matches. Okay, now create a post on that article. That's a function. So we'll say public string create post. And I think the post, oops. Yeah, the post has some content. No, it doesn't. It doesn't have any content. Okay. It probably should have some content. Let's update that. Spec string content. And this will take in content and it will return an ID. And this will just say return null. Now, we also want to be able to update a post. So public void update post, string post ID, string content. And this isn't going to do anything. This will just get called by this update post method. Similarly, we want to be able to delete a post on an article. So we'll write in the article interface public void delete post. And then we want to be able to add a comment on a particular post. So again, like if you were implementing this, you'd probably have some sort of, find the article we're talking about and then invoke a method on that article object. So that method should be here. Public void add comment, string post ID, string comment. Cool. And then on the post, we probably want to be able to, well, we can create it. That's just the constructor. We want to be able to update it. So we'll say public void update content, string content, and public void add comment. That's it. I don't think there's anything else. Does anyone think I might have missed something? Should we put the relationships in comments within each class file, or should we group all relationship comments into a single text file? Please do it as comments in the class file, in the Java file, because it will be easier for your marker then. Like we just want to be able to look at it and see list of posts, composition, cardinality, and then give you the marks there and then. The less files we have to look at, the better. Cool. That's all you have to do with this question. Very straightforward. You're just doing the prototypes. Try and just spend 10 minutes on it. Really don't burn time on this question because it's not worth it, and you don't have to worry about implementing the system, right? It's just the high level design. Okay. Let's talk about the programming questions. The thing with these questions, I would say, is that like people, I would say on the whole found them quite challenging. This in the exam last term. For this particular question 14, I'll talk about the question as a whole in a second, but most people did this bit okay. Most people did this bit okay. Maybe I would say about half of people got this question and half of people didn't. So if you're like, if you're feeling as though, oh, you know, this sample exam is really hard, like, you know, I'm going to do really badly or whatever, it's like a lot of people find this quite difficult because it is challenging and it is testing your ability to really get to grips with the concepts. Not many people got this question, and this is not very difficult. I think it's a question that you kind of have to plan for. We'll do that in a second. The patterns ones, some people got, but it doesn't matter too much. Let's go through it though. So in GitLab, which you're all very familiar with, you have this idea of a group. And a group contains either other groups or repos. Probably see where this is going. So like here I have the 22T2 group, and then that contains a teams group, which has like all of your all project teams, and then a staff group, and then it has these repos inside it. So you can kind of map this out as being like a tree, where you have 2511, then 22T3, and then staff, and then in that you have admin, and this is a repo, right? This is a leaf node of the tree. And you also have tutor notes, you know, blah, blah, blah. And similarly, you have more groups and more subgroups, and subgroups of subgroups and subgroups, and eventually you get leaves on the tree. What design pattern is this?
Composite.
Yep, composite pattern. Cool. That's the first question. The code models the composite pattern that's provided. Again, you have to map the key characteristics. Now, in the code, let's have a look at the code. It's good to spend some time just familiarizing yourself with what's in the package. Like, okay, we're not going to worry about question 13 and 15. Just look on that left panel. Here's the files we have to deal with. Okay, this is an exception class, very straightforward. This is a factory class. All right, this is going to be a later part of the question. Don't have to worry about that now. Okay, GitLab group. This is our compound node. We're going to be working with this directly. So it's got some code, it's got some methods, all right. Yeah, that seems fine. And remember, you're thinking about how can we improve the design of this code? All right, we have an interface. Yeah, that seems fine. We've got some methods that do some stuff, and obviously GitLab group implements this interface. Okay, GitLab project, let's have a look at that. Pretty similar. And, oh, hang on, I might have seen some of this code before. And we've got this return null thing here. That's maybe a bit interesting. Same as we do here. Okay. All right. And GitLab runner, okay, that's part of a later part of the question. This is just an enum. and this is just a user. Okay, that's a data class. So with this sort of refactoring question, it can be easy to sort of get overwhelmed by the amount of code that you kind of have to work with. It's good to spend some time just looking over the code and say, okay, what are the key things to focus on? And for this second part of the question, it's like, well, what's the main design problem present in the existing code, and what smells are indicating the problem? So if we go back to these two classes, which were the sort of meat of our of this package, the first thing is, well, you know, this authorize method, I see that here, and then I also see that here. Let's bring it up side by side. Yeah, okay, so these two are the same copy pasted. All right. So we've got some dry going on. Similarly to JSON, that's pretty similar. Update user permissions, that's the same, copy pasted. Get user permissions, it's the same. Okay. So probably we can say that the main design problem is that there's repeated code between the GitLab group class and the GitLab project class. What smells indicating the problem? So that I would say that's the smell is dry, and the main design problem is that you think, well, okay, how would we change this, or like, why is there repeated code? Well, you've got this functionality which is clearly common to both GitLab group and GitLab project, like the fact that they have members, the fact they have a name, they do this authorization, you know, updating user permissions. But that's in two places when it should only be in one. What's the classic thing we do when we have two classes that both do the same thing?
Abstract.
We abstract, right? We pull out the functionality into a superclass.
Yes. Sorry, is that inappropriate inferencing? Is that what that is?
No, this is just plain old dry.
Okay.
Inappropriate inferencing is when you have two classes that are very tightly coupled and they keep sort of calling stuff from each other,
Okay.
kind of getting a bit frisky.
These ones have like similar methods, but they're not calling each other.
No, they're not interacting with each other. It's just repeated code.
Okay.
So this is straight out of Lab 2. Slightly different, but it's the same idea. There's repeated code, and we can abstract that. And we even have the abstraction already, right? The problem is, again, same as Lab 2, it's an interface when it should be an abstract class. So this is due to poor inheritance design. That's at the root of the problem. That's what you would need to say for this question. So really, this part of the question is you're planning for the part of the question where you'll do the refactoring, where you say, okay, well, think about what's going on in the code, where are the design problems, what are the smells? And which of the following design smells is also present? Now, the other thing that we noted when we were going through GitLab project is that this create subgroup is just kind of, oh, we're going to return null and not do anything, and same for create project. Does anyone know what smell that's called? It's called refuse bequest. It was in assignment 2. It's one of the big parts of assignment 2 where you had all those methods that were just doing nothing. And refuse, like bequest is when, comes from the word bequeath, where it's like there's a monarch or something, and you know the monarch dies, and then they bequeath the throne, or they bequeath the crown, and say, I bequeath you this thing, right? And a refuse bequest is when you say, well, no, I actually don't want that. And in this case, the GitLab permissions node interface has bequeathed these methods to the GitLab project class. And so I want you to implement these methods. And the GitLab project goes, well, I mean, it doesn't make sense for me to create a project or create a subgroup, right? Because this is a leaf node in the composite pattern. This is the trade-off between type safety and uniformity in the composite pattern. Because if you look at GitLab group, this class implements both of those methods, right? Because it makes sense. In a group, I want to be able to create a subgroup, another compound node, or I want to create a leaf node that will exist under me in a tree. But it doesn't make sense for a leaf node to do that. So this is just like the classic trade-off. we're not actually going to be able to fix this because if we do, the regression test will break. And another really important thing for this question is that you need to keep the regression test passing. So if we go to GitLab test and go up to this section here, which is regression test, and we just run those, you'll see that they pass. Here's our tick, and we want to keep them passing. So there might be an extent to which your refactoring is constrained by this. That's fine. We know what we need to do for part C, essentially, is we're gonna turn the interface into an abstract class, and we're going to pull out the common functionality. Before we get to that, this is like this is a nice question. All you need to do is change the imperative method into a stream. So if you understand streams, if you're confident with those, then this is pretty much a free 3 marks for you. And there'll be a similar question in the actual exam. So if we go to GitLab group, I'm just going to comment this out. And we're going to kind of go through and do what this code does, but do it in a string. So we'll say return members.keyset .string. And then I'm going to map. No, sorry, we're going to filter. Because what we do here is a conditional, so that's a filter. If it's inside the members, then we add the name. So I'm just going to say, well, dot filter member members dot get m dot equals level. Right, so we get all the members. Sorry, that should say members. Is this right? Members.keyset. Yeah. We check if all the members. We go through each of the members in the members dictionary and then check if they're equal to the permission level. Then we're going to map and say, well, for each of the members that survived the filtering, I want to get their name. And we can do that by saying user get name. Nice and fancy. You could do this using just like u.get name as well. That's fine. This is just nice syntax using the scope operator. And then collectors.toList. Easy. That's a stream. Okay, let's get rid of this. And now let's do some bigger refactoring. So we said, okay, let's pull out the common methods from GitLab group and GitLab project into the GitLab permissions node superclass. Let's start by making this an abstract class. Public abstract class, blah, blah, blah. We first need to go and change this implements to extends. And let's take these two attributes, which we see are common to both GitLab project and GitLab group. Let's take them and pull them out into the superclass. So copy, paste. Now there's going to be a lot of fixing up to do just because we've gone from interface to abstract class. You just kind of work through each of these and eventually there'll be no more red lines and we'll be sweet. Okay, what else is common? Get name and set name. Yeah, that looks pretty common. Let's copy this. Sorry, I'm just going to get rid of all these extra ones. GitLab project, here we go. Okay, and then let's get rid of that. Get users, get user permissions. That's common as well. Update user permissions. Yep, that's the same. And copy and paste that into the superclass. Now, create subgroup and create project, as we said before, with the refuse request are going to be different. So let's make these abstract. And then the last one, oh no, we've got this authorized method as well. That was repeated. So I'm going to copy this out of here and paste it here. This is just a helper function. Let's get rid of it. I think we need to make it protected because otherwise it's not visible to the child classes. We can make methods protected, that's all fine. The method authorizes, oh, let's just save, yep. We can make methods protected, that's fine for encapsulation. It's just when we make variables protected, then things get a bit funny. Cool, so we don't actually have much left in a lot of the classes. We still have this refuse bequest, which the problem is if you just get rid of it, then go to the regression tests, you'll see that some of these start, I think they stop compiling. Or I should say this class won't compile because it doesn't comply with this interface. So you say, well, all right, let's comment that out. And then, yeah, the regression tests start not compiling. So again, sometimes you can't have everything in refactoring, but the changes we've made are pretty good. So there's the toJSON method as well, which honestly, I think we'll just leave because it's kind of like there's probably about 2 lines of slightly similar code. It's not really worth making like a super method in this case. I'm sorry, my screen is so small. We just need to change this to getName, and we need to do that in the project class as well. Now, I think the only thing we have left is the constructor. Super name owner. The constructor is undefined. That's because we haven't made it yet. And I think inside the group class, we need to do this. Yep. Awesome. Let's move this method up into the superclass as well. It's not actually, this method isn't used in the regression tests, but it makes sense to have get users of permission level for both a project, right, like a repo, and a group as well. So no harm done there. Cool, and members is not visible. Everything's compiling, that's a good start. Oh, sorry, this isn't compiling. Must overwrite. Okay, now everything's compiling. I wish the screen was a bit bigger, but if you sort of click around and make sure that you kind of cleaned up everything, I would spend just like a minute or 2 doing that in this question, because you might have missed something, maybe a bit of repeated code. It's good just to make sure you cover all your bases. The other thing is that, okay, well, everything's compiling, that's good, but we still need to make sure that the regression tests are passing. So let's run that again. And green tick's still the same, we're all good. Okay. 554, still got a lot to go. I think we're gonna just crack on if people are happy to do that. You're welcome to leave and watch the recording in your own time. So that's part C. Part D, again, lots of people found this challenging. The solution is probably 3 lines of code, if that. And this kind of question is really testing your problem solving ability and going, can you understand the problem and be able to come up with a nice clean solution? Oh no, what have I done? There we go. I said this, I'll say this at the end again, but like there's, you know, I said this in think it was week 5 when we were doing assignment 2. But there's 2 types of like hard problems. There's the problems that are hard to understand. Once you understand them, they're quite simple to solve. And then there's the problems that are easy to understand, but kind of hard to solve. This question is probably not too hard to understand, but it's still like the design isn't immediately clear, which is I think where people struggle. So at the moment, it's like if you have permissions on a supergroup, then you don't have permissions on the subgroups. I'll go back to the board. If I have permissions on 2511, and then I have 22T3, and then I have exam, it's like if I'm the owner of this, then at the moment, I'm not the owner of this and the owner of this when I should be, right? Like if you're the owner of the parent, then you should be the owner of all the children in the tree. So what we want to do is say, well, when I add a new, when I create a new subgroup, the creator, which in this case is Claire, is automatically added as the user to the group. So in this case, or actually in this test case, I say, well, I create the group, I create the subgroup, and then I want to say, well, user 2, which is Eddie, has developer permissions on 2511, and that should filter down to 22T3 and to exam. So when I say, well, what are the permissions on group 2, which is, yeah, this one. What are the permissions on this subgroup, right? So we added them on the supergroup. We say, well, what are the permissions on the subgroup? Then it should be the same as the supergroup. And then similarly, if we try to say, well, I'm going to give them lower permissions on the subgroup, it's like, well, we've already, if I try to make you a developer here, or sorry, I think in this case, I try to make you a reporter here, but you're already a developer, which is like a higher permissions level, then that should fail. Sorry, I didn't give the earlier context of this question where it's like you have different tiers of permissions where it's like you're an owner, a maintainer, or a developer or a reporter. And these are like your rankings. And then there's like actions which require different permissions. You don't really need to understand this to do the question because it's implemented for you, but it's good to know the background. The point is for this question, we need to implement this idea of filtering so that when I add the permissions on this level, they get trickled down to this level here and to this level here. So that's kind of straightforward. And this is a good time to think, okay, let's get out pen and paper, let's draw it out. So here's my 2511. That has a certain set of members, right? That's, you know, it's got Claire. Because in the code, when we create a subgroup, the person who created it automatically gets added as the owner. If you look at GitLab group.java, where is it? Sorry, create project or create group, you see that they automatically are put in the constructor, which means that the creator is an owner. But if we want to add someone else, then they only get added at that specific level. So probably the changes we'll need to make come into play when I say, okay, GitLab group, GitLab permissions node. When I update someone's permissions, we don't just want to update the permissions on that current node, right? We don't just want to update the permissions here. We want to say, no, go through and do the same for all the children. Okay. That seems all right. Now, we don't have access to the children here because this is just a generic node, right? It could be a project or a group. Let's say, well, inside the group class, I'm going to override the public void update user permissions. Oops. And it's going to do everything it did before, right? So we just call the super method, which actually adds the user to the current set of permissions. But then what I'll also do is say, well, I now have access to the subgroups, right? The children. And they could be projects, they could be other groups, and it doesn't matter. But what I'm going to do is go and update those. So we'll say for GitLab permissions node in subgroups. Node dot update user permissions, and we just pass in the same parameters. And so what this will do is say, okay, well, we're inside 2511. We update the permissions for that specific user on 2511 and say, okay, let's go through all the children now and do the same thing. And because like this isn't recursive in the sense that you're calling the exact same function, you're calling the same method, but in a different object. And so if that has children as well, it'll say, okay, go through each of the children and update them. Does that make sense to people? Cool. So we've updated, we've gone through, we've managed the bottom of the tree, and you notice that when we get to the project nodes, they don't have this method, right? So they don't try and update more children. It's like this only applies for GitLab group objects together.
Was that subgroups list? Was it only holding the immediate children or all of the children, like the children of the children?
It's only holding the immediate children.
Okay, that makes sense.
But if we update the children, right, this calls the same method. Yeah, it's a subgroup. So it'll call update for its own children. So you get this like flow.
Yeah, because I was thinking.
Yeah. That's right. Now let's do that. Okay, let's see where we get to. Regression test passing, we'll run the test. Okay, we still fail because we expected an exception to be thrown, but none was thrown. So we haven't done the part yet where we say, well, if you already have a permission on that node, then you can't have that overwritten. Or I think in the exam, this was a little bit ambiguous because like maybe you could have your permission be greater than what it was before. Yeah, similarly, if a user tries to give permissions to another user on a group which by filtering authorization they already have permissions on, an exception should be thrown. Okay, so that's pretty simple. We just need to say, well, in the permissions node, if I already have permissions on this node, then I'm going to throw an exception. So we say, well, if members dot contains key user to update, throw new what is the GitLab authorization exception? Cool. So let's run that test again. And passes, woohoo. That's part D. Literally 5 lines of code. It's all in the thinking, it's all in the design. Now, this part of the question, you can choose one of two, so you don't have to do both, but we are going to do both just to actually, yeah, we'll do both. I'm just going to type it out. This first one with the factory pattern is straight out of Lab 7. So if you are confident with that, like the node factory in that lab and can just sort of go and do it, it's quite simple. The design's not really involved. Similarly, like this singleton one is, if you understand a singleton pattern, this is much faster, and it's all in the concept, really, is what I'm trying to say. So let's do the factory first. In this test, I'll show you the test of this question. Is you get given, you've already loaded in the resource file. So here we say, okay, we've got this new user, and then we get a string, which is this JSON representation of the permissions tree. And then we just check some stuff about the permissions and make sure that it works as expected. So what we're going to do is inside GitLab factory, implement a method which recursively creates these groups and subgroups. So the first thing I'll say is string or JSON object JSON equals new JSON object, and we can just pass in the string we get given. And I'm going to then call another helper function, which is going to be our recursive function, which takes in, we'll call this, I don't know, from JSON, which takes in a JSON object. And it also takes in a user. And then here I'll just say return from JSON. Sorry, JSON owner. Let's call this root. All right, so here I'm going to say string name equals node.getString name, and all we're doing is just manual extraction. So we get the name, we get the type, and then we're going to switch on type and say, well, if this is a group, then we want to go through and get all the subgroups. So we'll say JSON array subgroups equals node.getJSON subgroups. And then we'll just have a for loop, which says, for int I equals 0, I is less than subgroups.length. So we go through by index. This is the easiest way to iterate through a JSON array. And we'll say JSON object subgroup equals subgroups dot get I. Sorry, get JSON object. And then all we do is, what do we do? Well, we actually need to create the group object, the real object itself, right? This is what the factory is supposed to do. So we'll say GitLab group equals new GitLab. Oh, sorry. No, that's right. We'll pass in the name and the owner. So we've got our group, and then we're just going to add all the subgroups to the group. So we'll say group.add subgroup. Now here we can get back a permissions node. We don't have anything inside a group that allows us to add a subgroup. Sorry, I should make this more clear. At the moment, when we create a subgroup, we do it manually, right? We actually call the constructor inside the create subgroup method. But I actually just want another method which allows us to get a GitLab group object and then add that in to the list like so. So say GitLab group, sorry, public void, add subgroup, GitLab group. And then we just add that to the list. This helps us with the factory pattern so that we can then just say from JSON subgroup. And what's happening here is we're going to just call the function recursively. So we call from JSON, and that might be a project, that might be another group with more nested groups, and you keep going in further and further down the tree. And we need to pass in the owner as well. Is not applicable for GitLab permissions node. Okay, and then I'm just going to say return group. Now, once we get to the leaves of the tree, this is quite easy. If it's a project, then we just return new GitLab project with the name and owner. And then otherwise, return null. That's it. Factory pattern done. Let's run the test to make sure it works. One thing with this question that I wanted to make note of is that we use a switch statement, and that's perfectly fine. There's this interesting part of assignment 2 where we gave a switch statement, and the code was probably okay. This was the open close goals, but and a lot of people go, oh well, because there's a switch statement, it's not open for extension, closed for modification. And It's correct. Like in this sense, like if you have more types of nodes, like maybe we have some new kind of compound node, then yes, you have to go and add a case to the switch statement. But maybe that trade-off's okay. And similarly, like this is similar to the entity factory in assignment 2, where it's like, yeah, you have to, if you want to add a new entity, you have to add a new switch statement, but sorry, a new case statement. But you know, this is like 10 lines of code. We can deal with that. It's when you start having 20, you know, it's like if you start having lots and lots of lines of code for each case, or stuff's really common, you can pull out functionality, right? There's code smells left, right, and center that you think, oh, this is maybe a problem. So it's good to use your sort of design judgment and go, okay, well, this is a smell, but maybe there's no underlying design problem. And switch statements are not inherently evil. Cool. Okay. That's part E. Now the singleton pattern, pretty straightforward. So we have a runner. All the projects in GitLab run their pipelines on a single machine. That's why the runner gets very slow around the assignment deadlines. There's a run pipeline method which takes in a process that's just a like a function that doesn't take in any parameters and returns nothing. And it creates a new instance of the runner, runs the job. And we need to refactor it to use a singleton pattern so that we can only have one instance of the runner and only one job can run at a time. And we have a test of this. The test is failing at the moment. All we need to do here is just turn it into a singleton. And this is pretty much boilerplate from the tute or the lecture code. So we start by saying, well, I'm going to make a static private variable called GitLab runner instance. And then I'm going to have a private constructor, right? Because we don't want to allow other people to just make new instances of this object kind of willy-nilly. We want to control all the creation through a public static method. Public static GitLab runner instance. And we'll say, well, if instance is null, then let's say instance is new GitLab runner. And this private constructor will be fine here because we're inside the class itself, but this won't work outside the GitLab runner class. You'll say, no, that constructor is private. So we have to go through this public static method. And otherwise just return instance. So if it's new, then we create a new instance. If it's not new, then we just return the one existing singleton instance, right? So only one GitLab runner will ever exist at a time. Cool. Now, the only other thing we need to do is synchronize everything. And we need to synchronize this run method as well. So that only one block of code will access this at a time, and only one thread will access this at a time. That seems pretty straightforward. We've got our singleton pattern implemented. We notice there's a problem in the GitLab project class because we try to use the constructor, but of course it's private. So we just need to change that to say GitLab runner dot instance. Part at singleton, let's run that. And it takes a while because we have some tests that use a sleep function, but we can see everything passes. Cool. Let's run everything, just make sure everything's working all at the end, but that's this entire question. Happy days. All right. I won't take a break because we're already over time, but I want to do this question and show that it's not, people found this question challenging. Some people found it challenging. It's not a difficult question, but it all comes in understanding kind of what's going on and the concepts around it. And this is the Lab 8 question. So if you've done Lab 8 and if you understand this idea of functional decorators, essentially, where you can wrap functionality around by returning to the same interface in a sort of pipeline architecture, then this question will be pretty straightforward. I'll show you, again, there's multiple ways to do this question. but I'll show you the sort of Lab 8 style, which uses a decorator. It's a decorator pattern of sorts. And it's pretty straightforward. It doesn't take too long to implement. Again, it's all in understanding the design. So let's do it. We have this idea of an expect expression. If you've ever done testing with JavaScript or Jest before, this is where it comes from, or like this question comes from Jest. So I can say I'm going to create a new expectation. I'm going to expect the string hello, and on its own it means nothing, right? It's like I expect what? Well, I don't expect anything at the moment. But then I'm going to say, well, I want that expression to be to equal another string. So your final expression is like, I expect hello to equal hello. And then we evaluate the expression. So if it's true, then the assertion passes, we keep going. And if it's false, then we raise an expectation failed exception, which is just like a custom exception we've thrown. So here it's like hello is hello, so that's fine. And then we try to say hello, we expect it to equal world. That's obviously not true. So we raise an exception, right? Just like any other testing framework. So let's implement this class. Part A is just the very basic operations. And like Lab 8, you just get given a blank class, or a pretty much blank class. You get the prototypes. So, and we've actually already given you this inner attribute. So we store some sort of value inside. We don't know what it is. It's generic. That's the other big thing with this question, is that you need to understand generics. So be prepared for that. But this could be any value. It could be integer, could be string, whatever. In the constructor, I'm just going to say, well, this dot inner equals object. That's the start. And when we evaluate something, and this is the crux of this question, is to understand the decoration. So what I mean by that is, you start out with my value, hello. On its own, it means nothing. And when we evaluate it, literally nothing happens, right? Because you're not comparing it to anything. So this method gets left blank. But when we do something like, okay, well, I'm going to say expect e dot to equal hello, and I evaluate that expression, we wrap this object in another object that's like saying, okay, well, I expect you to equal hello. Now, we are not actually evaluating anything. We're just saying, okay, here's this sort of, it's almost like a bomb waiting to go off. Like, okay, here's my value, and I wrap it in this equal method. Okay, later I'm going to evaluate it. But I could do that anytime. I could pass this around to 50 million other classes and then evaluate it. So when we call this evaluate method, that's when the thing actually happens. Now, what we're going to do in the next part of the question is say, well, I'm going to, okay, have this value hello, and I'm going to wrap it in a comparison. And then I'm going to say, well, actually, I want to negate that. So when we evaluate it, I want that to be not true. Now, it only gets to a certain point where it's like, after this, it doesn't really make any sense to, wrap things further. You could have like, I guess you could have another not, where it's like, well, I want this to be not true. But actually, I want that entire thing to not be true. So then, like the negations cancel out. It's all like building logic and stuff. What does that mean in implementation? The way we can do it is using anonymous classes, and every part of this question we can do in pretty much the same way. So I'll start with to equal. What we're going to say is expect e parent equals this. And the reason we need to do that is because we're going to return a new expect e. And this is our anonymous class, where we actually return a new subclass of expect. And what we're going to do is we're going to override the evaluate method, because the way we evaluate a 2 equal expression is different to how we evaluate a regular expression, right? It's not just going to do nothing. It's going to actually say, no, let's do some comparison. So say at override, public void evaluate, and it doesn't take in anything, right? The prototype is the same as this one. But what we're going to do is, firstly, we need to evaluate the inner. And if you think of the decorator pattern that we studied, that's the first thing you do, right? Is you have everything done on the inside, and then you get to a certain like layer of the onion. So we'll say parent dot evaluate, and this might do something else. This might already assert false. We don't know what happens, right? We don't actually care because we're just adding a layer to the onion. And I'm going to say if not inner dot equals other, which is this value that we get given to compare to, we're going to throw a new expectation failed exception. And I'm just going to be lazy and say it was not equal. I think we didn't mark the message, so you can write anything here. So if it's not equal, then we throw an exception. That's like our assertion error. And then otherwise, well, we just keep going. We don't actually need to say anything. So this is the entire method, is just override the evaluate method so that when it's evaluated, we check if it's equal to the other string. And if it's not, raise an exception. Let's run this against the tests. Sorry, expect. And we'll start with test to equal. Tick, okay, that passes, good. Let's do the others. It's pretty much the same thing. It's reasonably boilerplate. So we'll say parent equals this, and return new expect e at override public void evaluate. We first do the parent. And now we need to say, well, if other dot compare to, because the other is a comparable object. So we say, well, this t other has to be comparable to whatever type of object that the expect is storing. So if other dot compare to inner is, now this is confusing because remember, like if you say, well, if 1 dot compare to 2 is going to be less than 1, it's like your you know, str CMP string compare in C. So if it's less than it, it will return -1. If it's greater, it's equal to, return 0. If it's greater than, it will return 1. The problem is we've kind of flipped it. So we instead of saying less than 1, we need to actually say greater than, or sorry, less than 0, greater than or equal to 0. Then we need to, then we throw an exception because it's the other way around. And you can't do inner dot compare to other because, well, maybe I lie, you can. Okay, never mind. Let's just do that then. If it's less than 0, throw new expectation failed. Oh no, I was right. Yeah, see. The method compared to t is undefined for the type e, but the method compared to e is defined for the type t. So we say other dot compare to inner greater than or equal to 0. Let's check that. Oh, we failed. Unexpected exception thrown. What have I done? Oh no, hang on, I'm the other way around. I'm still thinking the wrong way around. If the other is other dot compare to inner, so that's saying the other is greater than inner, but that's what we want. So it should be less than 0. Yep, cool. And then, I mean, I'm just going to copy and paste this because I'm lazy. But we'll reverse the sign and say not greater than or equal to. run that test. And this fails as well. Unexpected exception thrown. If other dot compare to, you know. Have I got this the wrong way around again? If other dot compare to, if the other is greater than 0, then can anyone help me out here? My brain's a bit fried. If the other is greater than or equal to 0, Parent.evaluate. Yep. If the other is bigger than the inner, which is not what we want. We want the other to be less than the inner. Then I don't think I know what's wrong. Try this. Less than. Yeah, I put the equals in the wrong spot. There we go. This is what tests are great for, is catching errors when you're like, I don't, you know, it's hard to immediately visualize what the code is doing. But anyway, so that's all of part A. Pretty straightforward, and it sort of paves the way for the rest of the question to be done as well. So let's do part B, which is all about the decoration operations. So you can see, now I'm going to negate an expression. So we could compare two strings, but then say, actually, I want that not to be true. So to do that, we'll say return, we'll do the parent again. And then we'll return new expect E, public void evaluate. What I'm going to do is wrap everything in a try catch, because what we want to happen in a not is say, well, if the other thing is not true and we evaluate it, then if it throws an exception, we know it's false, right? If we say, okay, well, hello, I want to equal hello, but I want that not to be true. We start by evaluating this one, which does nothing. And then we evaluate this one, which compares these two values. And if they're false, if it's false, then we'll throw an exception. So by the time we get to this outer sort of layer, we know that if any of the inner layers threw an exception, then it's not true. But if it didn't, then it was true, which is not what we want. Again, we've got all your reverse negation going on here. So what I'm going to say is try parent dot evaluate. And then catch exception, or catch expectation failed exception. And if we catch, we just return, right? Nothing happens, the test was a success. But if we don't return, if we don't catch anything, then we need to now say throw new expectation failed exception was true when expected not. These are some crap messages, but you get the idea. So let's run that. We only get a test for not, but we'll implement skip as well. And you can see that works. Now skip literally just says, no, I'm going to ignore everything that happened before. So when I evaluate the parent, or I evaluate the inner, sorry, when I evaluate the parent, which in this case is like the inner layer of the onion, we're just going to ignore the results of that, which is a very straightforward implementation. We just say return a new expect, which overrides the evaluate method, and skip, do nothing. That's part B. Okay, part C. runnable testing operations. This is where like your assert throws and your assert not throws, where you get some sort of runnable lambda, takes in no arguments, returns nothing, and then it'll run that. And if it throws an exception, then depending on whether or not we wanted that, it'll be true or false. Right? So if like you say, if I expect this to throw an authorization exception, then the test passes. If it throws an authorization exception. But if it doesn't, then the test fails. And same thing other way around, you can say, I'm going to assert that this will not throw anything. But we've already got the negation stuff, so we now just need to say, well, I'm going to check whether this exception was thrown. So what we can do is, it's inside a new class called expectRunnable. And this will do, again, the same thing. We just expectRunnable e parent equals this. Return new expectRunnable. Ooh. I think we need to make a private expectRunnable. This is just a another constructor so that this compilation doesn't fail, right? Because only the inner will only the innermost object will store a value. All the rest is just like wrapping paper. So we'll override public void evaluate, and in that we need to say, okay, well, we get given this exec, which we haven't actually stored yet. So let's do that. So private e exec, and this dot exec equals exec. So this is an executable, a runnable function. And I'm going to say, well, okay, I expect this to throw something. So if we wrap it all in a try catch, try exec.run, which runs the function we got given, and then catch throwable t. You could catch an exception or a throwable, it doesn't really matter. So there's several cases, right? It's like if you ran the function and it threw an exception, but it wasn't the exception that you wanted, right? It was a different type, then that's not good, the test should fail. And then there's also the case where you ran the function, you expected it to throw something, but then it didn't. So for that case, we'll just say throw new, expectation failed exception. This is where it gets confusing because now you're throwing an exception because you expected the other one to throw an exception, but these are sort of semantically two different things, right? One is an exception, one is an assertion. Does that make sense? Yep. No exception or did not throw an exception. So that's the first case. And then the second case is, well, what about this thing here, right? We want to say, I'm going to throw a certain type of exception. And we can just do that by our good friend getClass. We say if t.getClass is not equal to CLZ, throw new expectation failed. Exception was thrown, but of wrong type. And that's it. And we don't even need to implement does not throw because we've already implemented the not operator, which if we run these two tests, you'll see that, oh, sorry, one passes and one fails. Unexpected exception thrown. Okay, did not throw an exception. What have I done wrong?
Is that the following?
Sorry?
Is that the try catch following? Is that the others going to be catching up?
No, because that'll do the same thing. I just realized what I haven't done here is return, right? This is our success case. We don't actually want it to get here if we compared the types, they were true. So now that's it. We don't want to get to this. This is only if the exception wasn't thrown. So that should work now. Tick. Cool. All right, part D. This is a tough part of the question. This is particularly difficult. There'll be a kind of question like this in the exam, which is really just your differentiator kind of question. So if you don't get it, don't worry too much. It's meant to be difficult. What you have to do in this question is write an iterator that allows a user to parameterize tests. So you might have a testing function which has a parameter, right? Like it's an unknown variable. And you want to say, well, here's the function and here's all the possible inputs to the function. Give me an iterator which will spit out executables, which I can just say, okay, run this, and it'll run the test. So here's an example. We have a function which takes in a parameter, I, which is an integer, and then it runs this test based on this value of I. We don't know what I is at the moment. It's just a function. And then we say, here are all the possible parameters that we can give to that function. And so when we say, okay, give me an iterator to this expect parameterize, it will give you, like, it'll sort of bake up an executable, which will say, okay, well, here's the first one is where I'm going to run this function where I equals 8. And the second one I'll run it for where I equals 9. So in this case, this all passes fine because 8 is less than 10. 9 is less than 10, and then when we run it for the third one, it gets to, okay, well, expect I less than 10, but I is 10, 10 and 10 are equal, so the test fails, right? Exception gets thrown. Make sense? Yep. Cool. Now, to implement this, it's again not that many lines of code. It's just all in the thinking. So we get given a consumer function. Again, that's like the cookie monster, takes in a value but doesn't return anything. And then we get given some parameters, which is just a list of arguments to the consumer, right? So the consumer takes in object of type T, and then we get a list of T. I don't know, I mean, we probably don't even need this L thing. You should just say list of T. But it gets a list of T objects to feed to the consumer. Now, I'm going to use anonymous classes again, just because it's a bit like syntactically nicer here. So I'm going to say return new iterator runnable. You could make a whole new class this if you wanted to, where this just like goes in its own file. And I'll say at override public runnable, or public boolean has next, and public runnable next, right? These are the two methods that we need to implement when we write an iterator. Now, what this iterator is going to do is say, well, I'm going to go through all of the parameters and feed them to the consumer one by one. Now, the easiest way to do that is just say, I'm going to store an index, which is initialized to 0. And then when we say, well, are there any elements left in the iterator, we just return index less than parameters dot size. Nice and easy. Now, here's where the magic happens. We've got this consumer, and we've got a parameter to feed to the consumer, and we want to turn that into a runnable. And the way to do this is using a really, this is a concept in sort of functional programming, and is a big part of the functional paradigm, which is called lazy evaluation. And it's like what we were kind of talking about before with these expect objects. Is like I created an expectation, say expect hello. Okay, I expect it to equal hello, and then I negate it. But we don't actually do any evaluation, right? We just create those objects. And we could just leave it sitting there, like this bomb that's waiting to go off. But then eventually, we say, okay, now I'm going to explode the bomb. I'm going to evaluate the expression. Oh man, we're really going over time. We're almost done. So what we're going to do here is say, well, t parameter equals parameters dot get index. Okay, so we extract the parameter from the list, and then I'm going to say runnable equals a lambda. So this is going to sort of bake up a function which says runs consumer.accept parameter, and then we just return runnable. So what's happening here is this code is not getting run. This is the key idea. This line here, consumer.accept parameter, is not getting run when this function is run. It's getting sort of baked up into a cake and packaged off, so that when the runnable gets executed, right, runnable.run, then this function will run. Then it will actually accept the parameter, and it will say, well, you passed or you failed the test. Are there any questions about that? Again, tough question conceptually, but very simple when it comes to implementing code. Cool. We are way over time, so I'm going to keep my spiel about exam advice short, but I've lost it again. Sorry. Give me 1 second. Here we go. Nick's advice on how to approach the exam. As I said, easy to solve, sorry, easy to understand, hard to solve, hard to understand, easy to solve. We have to deal with both. The questions we've written so that you can understand them easily. But sometimes there's just like, there's an element of you kind of need to read the question again, or you just need to take a deep breath. And my biggest piece of advice about the exam is just try and relax, which I know is like, not relax the exam, but just if you're feeling strung out, if you're like, I don't understand the question, you know, this isn't making sense, my design isn't, you know, it's not sort of coming naturally, take a deep breath. If you can't do a question, just move on to the next one, let it sort of sit in your brain for a bit and then come back to it. The reason why people do badly in this exam is because they rush, they get overwhelmed, and they don't read the question. They don't read the question properly, and they go down the wrong path of design. And yeah, don't rush the short answer. Don't spend too long on domain modeling. Pick which choice parts you're going to do at the beginning. And say, I'm just going to do the factory pattern, or just a singleton pattern. And most importantly, you'll be okay regardless of how it goes. And so, you know, there's many marks for design, so if you don't pass all auto tests, you'll still get marks for how you've gone about solving the problem. If you find, this is another good rule of thumb, if you're finding the exam hard, everyone else is probably finding it hard as well. And as we said in the lecture, if we need to, we'll scale it. So don't feel as though like your performance in the exam, like it's what I would say, it's mainly like a race against yourself. And like one of the things I've seen a lot this term is people going, oh, you know, what about the online exam and, you know, blah, 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 and just like, don't worry about that. Just focus on doing the exam, do the best you can, understand the concepts, be able to think and solve problems on your feet, and you'll be fine. Okay, I've really kind of gone through this already, but there's some questions. There's questions about design patterns, questions about principles, blah blah blah. There's a question where you have to do some refactoring, like we did. There's a question that's like Lab 8, and I don't need to go. I was going to go through this and say which topics are covered, but really everything that's not marked as bonus is covered. It's fair game. The best way to prepare for this exam is do the sample exam. If you do the sample exam and you're like, I can't do a lot of it, or like I'm struggling with it, hopefully this live stream helps. We'll post the solutions tonight as well for you to look at. But really, like, focus on being able to solve the problem. This is why we don't give solutions to labs as well. It's like, because it's like, if we give the solutions, then you just learn the solutions, right? Like the point is not the solution, it's how you got there, right? For design. So what I would say is just like focus on being able to get a problem and figure out the solution, which is easier said than done, especially under pressure, but you're all very smart people. Okay, are there any final questions on anything that I've talked about today? Otherwise, we can all go and have dinner and enjoy the rest of our evening. No, all good online, all good in person. Thank you very much for coming and for watching. If you're watching a recording, I'll stand here. Have a great evening and good luck, and post in the forum if you have any questions. Thanks. Oh man, there's like 4 people left.